My name is Samir Anbar. I'm a mechanical engineer. I have 12-year experience in mechanical engineering. I will talk about BIM automation for mechanical engineering design. As a mechanical engineering, we have a problem, and because mechanical design engineering take a lot of time and a lot of repeated process. So we will talking about how to solve this by automation for mechanical engineering design. The main problem, like I told, in an MEP, or mechanical or electrical process, we have a lot of repeated, installation for duct, like supporting for duct, for example, or for electrical. So we have to make automation for this repeated process. So we will use automation. To use automation as a research, we have, or for myself, I have two ways to use this. Try to searching for one tools and going deeply on this tools to research on these tools, or researching for a lot of tools, but not go deeply in this tools. That's what I did in this research. So to put this researching method, I have to research firstly literature review. Started from BIM. So I started from general topic like BIM. After that, I go to specify it until I will reach to automation of MEP design. I started from BIM concept. After that, automation of design and MEP. After that, searching in parametric design and generative design, automation of MEP and BIM. To put this in methodology of research framework, we have two factors: input data, standard and specification we follow, and process and output. This is our flowchart. We were working. We have input data. I take it architecture 3D model and the structure 3D model. This structure 3D model I take it from company I'm working with. This collector cooling. I'm working with this company in Slovenia. This is the biggest contract company in Slovenia. So we are lucky here really in PMA Plus, because he gave us opportunity to work with company, like huge company like collector cooling or any company else, but it's very, very advanced for PMA Plus master. As a process, we follow the parametric design, generative design, dynamo, and clash detection and validation. As a standard as a mechanical engineering, I follow BIM standard and HVAC standard and firefighting standard and plumbing standard. That's standard for our discipline as a mechanical engineer. So I follow this. After that, we have output. I will discuss about this. First, as a framework in generative design, like you will know, or some of us know this about generative design. Generative design means, if for example, as a mechanical engineer, if we have one room and you distribute the grill, and you need to make connection between this grill or diffuser, square diffuser. You can make it by your design, or you can ask or take help from generative design to make connection between this diffuser. This enhance your design and give you multiple choice to choose which one is the better for frictionless and reduce the material and whatever. And another tools we can use it for automation. It's a Dynamo. In Dynamo, we have a lot of nodes or program helping to facilitate our design, like I told before, like support or insulation or something like that. Another thing is clash detection and validation. Clash detection means in mechanical design, we have a lot of MEP special. We have a lot of discipline, like firefighting like this, or water supply and the drainage and plumbing and HVAC and heating. So all of this make a lot of clashes. So to solve these clashes, we have traditional way to go and solve it, or make it by automation tools, like we discussed about. After that, we have validation tools, which mean, and sometimes we have engineers working with me. I give him some detection to solve it. He has some detection like this pipes. This pipes before is clashing with duct. So to solve this problem, this engineer cut this pipe and give me, okay, now I don't have any clash detection. But as a validation tools, automation for BIM can catch this problem, and I can make another report to this engineer to solve this problem again. Okay. Another tools, our friends talk about this before. It's when you have building like this building, small building, can determine which area have a good enough space for our discipline. This will not talk about this, but I just mentioned. And another for this drawing, this, for example, this tunnel, we have to make a meeting coordination between all civil engineers and determine where is the duct will going, where is the pipe will going, and distribute everything to make coordination before we starting work to decrease the clash detection before we start. As an input data, I take this building using as a conference building for university, this architecture model, and this for structure model. And this was as an input data. To start it, design in generally in BIM, you have to follow the BIM standard. BIM standard like ISO and whatever. We have to know what we need to do. Started from organization information requirements from the client, or project information requirements. All of this progress or sequence requirements, we learned it already in BIM A+ masters, how to do this, how to follow this progress to take a good BIM project. After we finish this whole process and know what level details we're working on, we're going to start it in parametric model and generative design and parametric design and clash detection and validation. First one I working in on this model parametric design is design the duct system for this project. After that, plumbing system and firefighting and electrical work. To make generative design, for example, for duct, like I said before, I distribute the grill inside one room, for example, and start asking generative design as a BIM automation tools to give me the routing of the duct. This one solution, this another solution. This I think this is best solution because it's more efficient. As a mechanical engineer, we have experience to choose which one is perfect. And I think we have another automation tools, maybe we'll develop after that, can give us the perfect solution more than depending on our experience. And this for firefighting, we have distributed the sprinkler, and we have one choice, two choice, number 3, for pipe distribution and same. This for plumbing, generative design for pipes, connection between the fixture units and the pipes. Another tools from automation systems is Dynamo. We use Dynamo as one of automation systems to develop or to solve a repeated problem, like a repeated process, like installation, like supporting, like whatever any repeated work. This can decrease. Maybe I can stay 3 days to finish installation for one project. With this tools, small program in Dynamo, we can solve it in just 2 minutes. After finish this, after use this tools, we make all installation for this project just for 1 minute without any effort, like before. After we use automation system. We use another tools from automation is using tools like Solibri. Solibri is to find the clash detection and validation, where we put all IFC files from our project inside the Solibri and make rules to find the clash detection. And we have inside these rules, we determine which rules we needed, like clearance between door and for example, WC in WC room. After we make run for this clash detection in these tools, we found here just, for example, clash between fan coil unit and firefighting pipe. And for example, here we have another problem between firefighting pipe and duct. And here for planium, for grill, we have clash detection. All of this, I make report for my engineers to give him report. Please, you have one problem here in this area. Please solve this problem and resend this project to me to check. After we check, like I said before, we have to make validation because some engineer cuts the duct to solve his problem and tell me I don't have any clash, but it's happened. So I have to make validation. Validation means if I have pipe, I have to ensure this pipe is connected until from the start until the end, and the flow can working in this pipe. So I use this Solibri to make this validation. For sure, we have a lot of another tools, but I will not go deeply to in specific one, but I just searching for our tools in generally. And this all of these tools can help us to decrease or reduce the time and save the cost of our system. For further work for myself, at least, I will start to searching for PhD for automation to enhance interoperability between BIM tools and facilitating of construction and demolishing waste management to decrease the demolishing and when you make demolishing for any project, I will use these tools, automation tools, but in this research and PhD, I will go deeply in one tools to find the solution for this problem, demolishing waste and construction waste. Thank you. Any question?